Array lists are an extension of the idea of an array. Like arrays, array lists can hold collections of objects. Unlike arrays, array lists can be resized and hold objects of different data types, yet they cannot contain data primitives. Today we're going to take a look at the ArrayList class of object in Java. And we've been studying arrays of objects and arrays of data primitives, simple data types, programmer-defined data types, and classes. The array list is just sort of an extension of that idea. And if you're a C++ aficionado, and a lot of people that come into Java have had some C++ experience as well, then you could compare an array list object to a vector. You know how in C++ in the standard template library you have vectors that utilize iterators? Well, an array list object would be the same. So let's review some of the limitations of a standard array. Remember, a standard array is a collection of objects referred to as elements, and they're indexed with a subscript value inside the array. But there are certain limitations that must be applied to an array. All the objects must be of the same data type. Okay, and then another very important limitation of an array is that it can't grow or decrease in size. So it cannot be augmented nor can it be diminished as needed, either to save memory or to accommodate more objects. Now, an array list class object does not have those restrictions upon it. So let's take a look at some of its capabilities as well as some of its limitations. First off, again, an array list cannot be used with primitive data types. So not like integers or doubles or floats or anything like that. It needs to be used with more sophisticated data types like classes that you write yourself. Second, array list objects must be cast to the appropriate data type when accessed in the array, and we'll go over an example of that, or declared in the declaration of the array list, and we'll also go over another example of that. Unlike arrays, array lists are dynamically resizable, so yes, they can augment and diminish in size, they can grow, and they can shrink. Unlike arrays, array lists can store multiple data types. When this is the case, again, the object must be cast to the appropriate data type when accessed. Let's take a look at some commonly used array list methods. Here are some of the relevant or pertinent methods that you'll be interested in when you use array list objects. There are several overridden add methods, and you can pass in one argument or parameter to an add method, just to add an object to an array list at the next available location. You can also pass in two arguments or parameters to add an object to an array list at a specified position. And then you could also relate this to a stack with iterators and vectors. But then there's remove, if you want to remove an object in an array list at the specified position, the argument that we'd specify here. There is set to change an object at a specified position. There is get to fetch or return an object at a specified position and render its value if you choose. And then there is size to return the size of the array list. That's kind of like the length attribute with arrays, okay? So those methods there would be fairly important. Example 1, building an unspecified array list. An unspecified array list can hold objects of more than one data type, but you must cast each object to the correct data type when you reference it. So let's go ahead and take a look at example 1. And I'm going to comment out example 2, and we'll just run example 1 for now. So in example 1, we are going to build an array list. And we're not specifying the data type or the type of object in the beginning here. So, in this example, we're going to have to do casting. We'll have to cast the object to the correct data type because it wasn't specified at the array list creation. Right, now, again, in this example, we could also, store objects of multiple types, but, in this case, we're instantiating or building an array list object called characters. When we do that, we're going to use the add method, and, we're going to add 4 string literals here: link, Zelda, Midna, and Zant. All right, just using characters.add. So that's the first method we're going to call. The next method we're going to use from the array list class is size. And we're just going to display something on the console. As we begin our story, there are, and in this case, if you count them, 0, 1, 2, 3, indexed appropriately, but size would render 4. There's 4 elements in the array, or 4 objects in the array list, so size would give us 4 characters. The chosen souls of fate and destiny are, and with this for loop, we're just going to go through and iterate through the entire array list and list all the objects stored in it. And that's what this is. X starts at 0. All right, that's the initialization. The condition part is it's going to keep iterating in a for loop until x is no longer less than characters.size. Well, again, the size method from our ArrayList class object simply returns the number of elements. So 4. So if you count, it would go 0, 1, 2, 3, and then when it gets to 4, it'll fall out of the loop. So 4 times, off by 1, because we start at 0 and not at 1. And the update portion, again, we're just postfix incrementing x. So in this for loop, we go through and we're going to add 1 to x to counter that, starting at 0 issue that we have. Humans like to start at 1, computers like to start at 0. So that it'll display 1, 2, 3, 4 instead of 0, 1, 2, 3. That's the only reason we're doing that. And then otherwise, we're just concatenating these string literals to the value that we get from our ArrayList object. Now again, since we didn't specify the data type up here in this declaration, we have to do some typecasting. Alright, so we have to cast it to a string because these are all string values. So we call the get method on the index or subscript value, which is x. You remember x is going to count up 0, 1, 2, 3, so it'll be get 0, get 1, get 2, get 3. And we're just going to cast it to a string. And all that's going to get, concatenated, or pasted together into a big string and displayed. So it'll display all of our characters. It should say link, Zelda, Midna, and Zant, and prefixed with the number 1, 2, 3, 4. Next, we're going to call get, and we're going to get the very first, object stored in our array list, which is link. It's the string link. So we'll assign that to the string hero, and we'll say the hero of our story is, and it should say link. Okay. And then we're going to get the very last element, our object in the array list, Zant, and we're going to assign that to a string called villain. The villain of our story is Zant. Okay. And now we're going to, say after, in this case, link vanishes the villain, which is Zant. There are only, and we're going to remove the very last one. Remember, that specifies that we can remove an object in the array list. Well, if they're indexed to 0, 1, 2, and 3 respectively, if that's the subscript value, then removing the third, removing 3, object 3, will remove the very fourth string. Again, remember, it's off by 1. We start at 1, computer start at 0. So 0, 1, 2, 3 is actually removing the fourth object in the array list. So remove 3. When we do that, if we call size, instead of rendering 4, now it's going to render 3 because we just removed one of those objects. Okay, it was taken out of the array list. And then those who live happily ever after are, and then this is pretty much we can just code and paste the same code we had up here down here. We don't have to change even a single character because size is dynamic and it's going to give us the number of objects in the array list, whatever we do to it, adding things, removing things, whatever. So let's run the example and see what it looks like in output. As we begin our story, there are 4 characters. These chosen souls of fate and destiny are Link, Zelda, Midna, and Zant. The hero of our story is Link. The villain of our story is Zant. After Link vanquishes Zant, there are only 3 remaining. Those who live happily ever after are Link, Zelda, and Midna. Okay, so you can see in example 1 how that works with the ArrayList methods. Now let's take a look at example 2. Example 2. Building a specified array list. A specified array list can only hold objects of one data type, and you do not need to cast each object to the correct data type when you reference it. Okay. In example 2, we don't have to do any casting. And the reason is we're going to specify, sort of pre-specify the data type of the collection of objects stored in our array list. In this case, it's going to be from the string class. Alright, so if we pre-specify, just using the greater than, less than symbols here and here, then we don't have to do any casting. And we can pretty much kind of treat it like an array, except that instead of using the square brackets, we call the get method. And then we'd pass in the index or the subscript value of the object stored in it. So once again, we're building an array list. It's called items, or the instance of it is called items when we instantiate it. Alright, and then it's going to be, in this case, an array list limited to a single data type, that of string. We're going to add 4 strings here, and that's going to be slingshot, claw, master sword, and boomerang. If we call remove 3, again, remember that off by 1 issue, same with arrays. It doesn't go 1, 2, 3, 4, it goes 0, 1, 2, 3. So if we remove 3, we're really removing the fourth object, the very last object in the array list. When we do that, we'll have a string called weapon trace. We're going to get the value stored at index subscript value 2. So if you count from 0, 0, 1, 2, that's master sword. And so we're just going to display the chosen weapon is, and it should say master sword, since we selected the index value of 2. So again, we commented out 1 and we uncommented 2, and let's build it and run it. And the chosen weapon is master sword. Example 3. Building an array list that holds objects of different data types. And here's just a third example. And I'm just going to illustrate constructing an array list that will hold objects of different data types. And to demonstrate this, I've constructed just a small class hierarchy. So here's my abstract data type, my ADT or superclass mythological. It has 2 private data members and the standard get and set accessor methods that are public to get at the data. And let's look at the child classes, the derived classes that are extending that class. Alright, so mythological is the ADT, it's the superclass, the parent, the children are dragon, Pegasus, Phoenix, and rainbow unicorn. And you can see that they each extend mythological. And we just added, they're displaying in the constructor when an object is being built what that object is, and they're setting the species automatically when we build the class to be that class of object. Okay, so that's how that works. Okay, so let's take a look at our example. Now this time we're building an array list and it's not predefined, alright? We're not specifying the data type like we did in example 2. Remember, we did that in example 2. We couldn't do that in this example because we're storing more than one data type in this array list. To illustrate that, first I'm going to add 3 strings, and these are just string literals, okay? And remember that we can use a for loop very easily with an array list, just like we can with an array. And because I haven't specified the type, then I call the size method. That'll find the number of objects stored in the array list, in this case 3, the first time running the loop. We're adding 1 to x just to offset for the 0, because computers start counting at 0, humans start counting at 1. So it'll go 1, 2, 3 instead of 0, 1, 2. Not a big deal there. But we have to cast, we have to typecast the data to the appropriate data type because it wasn't pre-specified. So here's the array list name. We're calling get to fetch the object, in this case a string. X starts at 0, so it's going to go 0, 1, 2. And we're casting that data type to a string. So it'll say strawberry sprinkles, fanciful unicorn, pure concentrated evil. Now here we're removing 2 just to illustrate the remove method. And that's 0, 1, 2, so we're wiping out pure concentrated evil. A good thing, right? 2 is actually indexing the 3rd object in the array list. Now we're going to display it, and now size, instead of returning a value of 3, will return a value of 2. We can see that there's 2 items. And we'll simply say introducing strawberry sprinkles and fanciful unicorn. Okay? And then we get down here and we're going to add a 3rd string, bronies. Okay? And of course we had to do that. So then we get down here and system out print, after adding another string we have, and again now size will return a value of 3, and we'll display 1, 2, 3 what those string items are. Now all of that was string data, so we haven't really added anything of a different data type yet. So now when we get down here we're going to add objects of multiple or different data types. So now we're going in our array list we're going to create a rainbow unicorn, a dragon, a Pegasus, and a Phoenix. Okay? We're going to display a line. And here's a neat trick we can do. Now, since these are all different data types, how could we create a for loop that would display that dynamically? We'd simply have to, normally we'd simply have to manually code that. System out, print this method from a rainbow unicorn, a dragon, a Pegasus, Phoenix, whatever, blah, blah, blah. But because of inheritance, because they're in an inheritance hierarchy and they all extend mythological, we can use, forgive this statement here, because people like to say there's no pointers in Java. There are a bit, Java hides them from you. But because we essentially have objects, in memory that, point to a superclass or a base class object, we can use that object at the top of our inheritance hierarchy, and we can cast to that object, we can typecast to it, even though we have a rainbow, unicorn, a dragon, a Pegasus, and a phoenix, they're all extending mythological. So we can just cast to mythological, and that way one size fits all. This one little line of code can handle 4 different objects because they're connected in our inheritance hierarchy. And so we'll take a look at that when we run the for loop. So we do that. Now the other thing is we have to start at 3 here. I want to make sure that I skip 0, 1, and 2. Why? Because 0, 1, 2, remember those were our 0, 1, and 2 were our strings there. Well, we got rid of pure evil, but then we added bronies. So still 0, 1, 2, that's string data. And if I were going to display that, then I pretty much would not be able to do this. I'd have to cast the first 3 to a string, and then I'd have to cast the last 4 to a mythological. So to avoid that, I'm starting at 3 here. So to go 3, 4, 5, 6. All right, 7 objects total, off by 1, or starting at 0. Now down here, this is an example of casting to the parent object. Here's another example of casting to, explicitly the child object or the class itself. And we're just calling the setName method to set the name Rainbow Sparkles, Wraithiar, Starshine, and Inferno on Rainbow, Unicorn, Dragon, Pegasus, and Phoenix. We have to cast to the appropriate data type when we do that, okay? Or else choose to use the parent object, the superclass object. Once again, we're in a for loop, and to illustrate the usefulness or the dynamic polymorph, the polymorphic functionality. There you go. There's a mouthful. The polymorphic functionality of an inheritance hierarchy and being able to cast objects to the superclass or the base class, object. Here again, we can kind of one line fits all or one size fits all. So a rainbow, unicorn, a dragon, a Pegasus, and a phoenix can all be cast to a mythological because they all extend mythological. Again, here's the class hierarchy up here. They all extend mythological. And then down here, we're just going to, again, we're going to call get name and get species. And to make, one size fit all, so to speak, to make our code dynamic or polymorphic, we're casting to the superclass, instead of the child class objects. Otherwise, it'd have to be a lot more code, and we wouldn't be able to do it in a for loop, and we'd have to be a lot more specific with things. So let's run it and see how it works. And let me scroll up here. Alright, so after adding 3 strings, we have Strawberry Sprinkles, Fanciful Unicorn, and Pure Concentrated Evil. And that's up here, right? If I scroll on the code, here's all the items we added. Here's our for loop, and we just iterate through it. Everything in the array list. Now we're going to remove what's indexed as 2, right? That's the last item. Right, so when we do that, after removing the 3rd string, what do we have? Strawberry Sprinkles and Fanciful Unicorn. Down here, we're just going to say, after this for loop where we've displayed the 2 we have left, introducing Strawberry Sprinkles and Fanciful Unicorn. Right, that's that statement there. Now we're going to add bronies, and then after adding another string, in this case now we had 2, now we have 3 once again. We're going to iterate through all the objects in the array list and display it. So we have Strawberry Sprinkles, Fanciful Unicorn, and bronies. Okay. Next, now adding multiple classes of objects of a different data type than string. Alright, that's what we're doing here. And that's where we're instantiating these classes of object in our inheritance hierarchy using the keyword new. So new Rainbow Unicorn, a new Dragon, a new Pegasus, a new Phoenix. Look at the inheritance hierarchy. Alright, so it calls the superclass constructor mythological, and then the child class builds a Rainbow Unicorn. Calls the superclass mythological, and then the child class Dragon. Superclass mythological, the child class Pegasus. Superclass mythological, the child class Phoenix. So you can see how the constructors are being called in the inheritance hierarchy as we add them to the array list. Okay. Then we add a line, and we're just going to iterate through the objects in our array list, but sans the strings, because we're casting to a mythological, not a string. So we're going to skip 0, 1, and 2 and start at 3. Otherwise, we'd have to code it differently. Right, so if we do that and we cast to this, notice what it gives us over here. Here's the type of object. Even though they're all mythological, it's given us the child class object Rainbow, Unicorn, Dragon, Pegasus, and Phoenix. And just some hex values there. Finally, we get down to our last loop here. We're going to name all of these objects, so we set names on them. And then in this last for loop here, this is where we're going to iterate through, and again, To make it polymorphic and kind of, shorten the amount of code we have to put in here, and to make it more useful with the for loop, we're, casting to the superclass or the base class the parent object instead of the child object. And that way one size fits all, so to speak. And again, we want to make sure that we start at 3 and not at 0, because remember 0, 1, 2 are strings. 3, 4, 5, and 6 happen to be other objects. When we do that, it'll display the object type, it'll display the name and the species. And let's take a look at that and see what happens. So 4 is of object type rainbow unicorn, sans to hex, name is rainbow sparkles, species rainbow unicorn. 5 is object type dragon, name Wraithior, species dragon. 6 is object type Pegasus, name Starshine, species Pegasus. And 7 is object type Phoenix, name Inferno, species Phoenix.